Good morning, everybody. Welcome to day 20 of Math 133. We got a fun one today. So, we're gonna start our candy project. Um, Everybody can see my screen, okay? All right. Um, yeah, today, if you click on Canvas for day 20, there's two things that we need to do today. One is the info and the pictures, and the other is data and some graphs. Okay. We're going to use this data that we're collecting right now for our Chapter 9 project, which is going to be on Thursday. And then we're also going to be using this data for the Chapter 10 project and the Chapter 11 project. Okay. So today, though, is just collecting the data. And that's an important piece of statistics. Collecting the data, cleaning it up, making sure that everything looks good. That's you know, even before you do any analysis, that's an important piece. Sometimes you as a data analyst are the one collecting the data. Sometimes it's on, the business to do it. And you have to make sure that they're doing it appropriately. Otherwise, the data that you get is biased, and then it's not usable then. It's not accurate. Um, so go to Canvas and click on both of these links, one for the info pictures and one for the data and the graphs. And it's going to bring you to these two different Google documents. So for both of them, we're going to do File, make a copy. All right, so this one, let's save this one in here. Okay, you got a copy of that. And then this one for the data and graphs, we'll do File, make a copy. This one as well. Um, I find it's easier to work on these two at the same time. So there's that one. All right. So for the data and the graphs one, we're going to be counting how many of each color we have for our M&Ms and our Skittles. We'll create a bar graph for our M&M data and a pie graph for our Skittles data. Um, and then for our pictures, uh, we organize the candies by color on a flat surface, and then take a photo, submit the photos of your candies here. So M&M's picture, Skittles picture. So today's pretty quick. Today's not particularly complicated. Um, uh, 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 uh. so yeah. Let's. So, uh, I have a cookie sheet. It is clean, but there's some. When you zoom in nice and close, it doesn't look so good. But anyway, pulled it out of the dishwasher today. I'm doing peanut butter M&Ms because those are by far the best. So, um, and my bag is 9 ounces. So if you're doing larger M&Ms like peanut butter or peanut, you want a little more than if you were doing just the normal M&Ms. I don't know. Is anyone's favorite just the normal ones? I don't know. I find that weird that like I like chocolate, sure, but just the normal ones, like when you could have, they've got all kinds now. They've got caramel and peanut butter is the best. And we'll just sort them by color. Um, So yeah, so if you have a smaller bag that's only 5 ounces with this, that's fine. Um, with the normal M&Ms, you could probably get away with 3 ounces. But so remember when you are collecting your sample, and we're basically going to count this as our random sample of M&Ms. When we're doing a random sample, you need to make sure your sample is not too big, right? But also it has to be big enough, right? So when we say big enough for means, your sample has to be larger than some number, right? For proportions, there's a little bit of a formula, and that has to be larger than a certain number. So does anybody remember when you're checking the central limit theorem for means, how big does your sample size have to be? Does anybody remember? This one's like perfectly spherical. This one looks like a gobstopper. Hmm. For means, your sample size has to be bigger than 30. So, uh, for our purposes, we are not going to be looking at means for this stuff. We're going to be looking at proportions. So, for proportions, there was a formula. It was N times P times Q, and that has to be bigger than a certain number. Does anybody remember what number that is? N times P times Q has to be bigger than, it's not 30. N times P times Q has to be bigger than 10. That. So how do you make sure that's big enough? Well, your N has to be large because remember, P and Q are are probabilities, so they're always going to be between 0 and 1. So if you need your number to be bigger than 10, then your N has to be large. Your sample size has to be large. Okay. Um, So for our case, the proportion that we're going to be looking at for these projects is we're going to be comparing to try to figure out the population proportion of each color. So for M&Ms, how many colors are there? 6, yes. So uh, now there's 6 colors. Do you think that there's any particular color that they create more of or less of? Um, so I think, and I guess we should probably verify this. Me and Elaine should verify this at some point that they produce these in equal measure. So you know, they produce 1/6 of all M&Ms are green, and 1/6 are red, and 1/6 are yellow. Um, right. I don't know if anyone's ever like looked at it and been like, "Hey, there's not very many blue M&Ms in the world." So our sample size is this bag of M&Ms. Our population is all M&Ms in the world. So we're going to be estimating, uh, as long as our sample size is big enough, we're going to be able to use this data to approximate the proportion for all M&Ms. All right, that looks good. Um, so what did you miss? No, we're just sorting our M&Ms. And all right, so now that we've organized our M&Ms, we do an M&M picture. So, I have this fun uh, camera that lets me see my desktop. So, I'm just going to do a snip of my desktop, but you guys can just take a picture on your phone. There we go. And then once you've got your picture, paste it in here. Here's my M&M picture. All right. So we have two documents open. One is the info and the pictures. So, obtain your own data missing. Okay. Um, is anyone missing a color? Does anyone not have six colors? When did that happen once last year? All right, so over here on the data and graphs, we're going to fill in our counts. So first of all, for orange, so I find it easiest to count by fives. We'll split these guys up a little bit. You can count by twos if you want. 5, 10, 15, 20, 25, 29. All right. Blue, let's see. 5, 10, 15, 20, 25, 26. So if our sample is truly random, these numbers are not going to all be exactly equal, and that's fine. Oh, what color do I want next? Green. 5, 10, 15, 20, 22. So, right. What we're saying is we're not saying that our sample is going to be one sixth, one sixth, one sixth. Okay, right. This was a random sample, and so you're going to get some colors that you get more of, and some colors that you get less of. What we're saying that is that in the entire population of all M&Ms in the world, they produce equal amounts of each color. Okay. Oh, what did I want next? Next, I want yellow. 5, 10, 15, 20, 25, 28. Five, 10, 15, 16, 17. So that's my smallest one so far. All right. And then brown. I don't know why they I don't know why they do brown. I feel like brown is a not an exciting color, right? You could do purple or like pink. 5, 10, 15, 20, 23. Okay. All right. What's our total here? $29. I got 145 Skittles. Okay. That's probably more than you need. But again, higher your Skittle, or sorry, 145 M&Ms, the more you have, um, the more accurate your predictions are going to be. So you definitely need at least, I would say you definitely need at least 60. Wait, it's probably actually probably need at least 70, right? Because 60 times 1/6 is 10, and our n times p times q needs to be bigger than 10. If you have less than that, that's okay. How many total Skittles did you guys get? Or not Skittles. I keep saying Skittles. Andrew has 100 M&Ms. 100 on the nose. Wow. Lucky. Jack had 73. Okay. All right. So that's it for M&M. So now that we've got the data recorded, we can start eating those. I don't know if you eat M&Ms at 9:45 in the morning, but uh all right. So Skittles. So for Skittles, I also got a 9 ounce bag. This one's probably more than I probably didn't need 9 ounces. Probably only need 4 or 5 ounces of Skittles because Skittles are smaller. So. Um, and you'll notice, so for Skittles, there's only five colors: orange, green, yellow, red, and purple. That's fine. Uh, that's no big deal. But we're gonna make the same assumption with Skittles that, this is our random sample. They randomly mix the Skittles together and put them in the bag for you. But we're gonna make the same assumption that uh factory that's making Skittles, they make the same amount of each flavor, um, which means that if you looked at the population of all Skittles in the world, the proportion should be around 1/5. So I don't know. Maybe you don't agree with that assumption. Maybe you're like, I always like the red ones, and they never give me enough red. So maybe you think that they make less red than other colors. I don't know. For me, I don't like the lemon ones. They're okay. I mean, it's still candy, but actually, so which flavor are these? Yeah, for a while there, they were doing green apple for the green ones, and I liked that. Um, then they switched back to lime, and lime is like, okay, well, it doesn't taste that much different from lemon, and I already don't like the lemon. I like the lime marginally better, but and then they were doing the green apple. I liked those. That was good. I would say that these Skittles are going to be eaten pretty quickly at my house, but I don't know now. So we still have Halloween candy sitting on the counter, so that might slow it down a little bit. People will be eating the Halloween candy as well as the Skittles, but so if you are using Halloween candy and just opening like a bunch of little fun size bags, that'll still work as long as you're opening enough of them. I would say probably like five. fun-sized bags would probably be enough. So the question is, okay, if you have a single bag of random candy, or if you have five of the small ones, uh, like, is there a difference? And the answer is there shouldn't be. If if each of the samples is truly random, then mixing them together will still represent a random sample. Now, are they truly random? No, I mean, you're getting candy from your local store, which you could say is biased, but so um, when we were looking at the distribution of the sample means or the distribution of sample proportions, and we ran that like 1,000 times, you're basically taking a sample 1,000 times and then recording all of those means. And that gives you something that looks like a normal curve, right? And so the question that brings up the question, well, is it better to just have a giant sample that is 1,000 times bigger, or is it better to take 1,000 small samples? And the answer is mathematically, there is no difference. Okay. If you do one massive sample or you do lots of small samples, mathematically, there is no difference as long as they're all random. So in practice, which one is better? Well, that depends on your resources, but in practice, lots of small samples is slightly better because if there is a bias, because it's the real world, so doing random samples is difficult. If there is a bias, then one of your samples might be biased, but if only one of them's biased, then it's going to get, that bias is going to get overwhelmed by the rest of the other samples. So now, if they're all biased, well, then you have a problem. Um, but if you did one giant sample and that one giant sample was biased, well, then you're in trouble. So, okay, so I got my five colors of Skittles all sorted out. Do my picture of these. There we go. And let's copy this for my Skittles picture. All right. Uh, and that is it for this document. For the data and graphs, we have a little bit more to do. I got to count my oranges. Five, 10, 15, 20, 25, 30, 35, 40, 45, 50, 54. Yeah. So yeah, definitely got more Skittles than I needed to. That's fine. Means we'll have a lot to eat. Oh, what color do I want next? Green is next. One left or so. 5, 10, 15, 20, 25, 30, 35, 40, 45, 51. All right. Yellow. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So what is your favorite flavor of Skittles? Favorite color of Skittles? Said that mine was red. Yeah, red. Good. Orange. Okay. I like orange. 25, 30, 35, 40, 45, 46, 47. Lemon and oh, Elaine, lemon and green and lime.
Lemon and lime. Yeah.
Oh, see, I was complaining earlier that there's not enough red in my bags, and guess what? Red is the least lowest one that I have. It's Taylor Swift's favorite red. She has a song about red. That's not even a good dad joke. Uh, okay. 5, 10, 15, 20, 25, 30, 34. Oh, no, purple's the least for me. So I I was complaining and about my red count, but I mean purple's my second favorite. So all right, let's add these up. 4, 1, 55, 7, 30, 241 Skittles. How many did you guys get? Um, 121. Okay. Janica got 119, and that's two regular bags. Yeah. If you'd only had a single regular bag, you'd have had 60, and 60 is not going to be enough to satisfy the central limit theorem because um, 60 times 1/5 is 12. Uh, 12 times 5, 6 would be 10. Oh, you'd be cutting it real close. You'd be right at 10. However, that's if you are using P of 1/5, and we're not going to be. We're going to be using P hat because we don't know what P is. So your P hat is going to be much smaller. So yeah, you'd be in trouble. So good on you using two bags. That's good. Um, all right. So now that I've got my data here, we can start analyzing it. Now, we're going to be doing the heavy, deep analysis in the Chapter 9, Chapter 10 project. But one of the very first things that you do as a data analyst once you've collected your data is to visualize it. There are lots of things that pop out when you visualize your data. Looking at the numbers is fine. Okay. I can see that my red is the lowest in my M&Ms, and I can see that red's kind of low for my Skittles, but purple is my lowest. But that doesn't necessarily give me the size. Like, how small is this red 17 compared to the other numbers? I can do some differences in percents and stuff, but humans are excellent at finding patterns and seeing patterns. Um, you know, we're just starting to like use AI and stuff to be able to, do patterns and things. Computer vision is something that is a very high, complicated thing to do, but humans are able to look at things visually and see patterns right away. So, all right. So what I'm going to do is I'm going to take my M&M numbers here. I'm going to copy them into StatCrunch. Okay. So highlight those and you can right click and copy, or you can just hit Control C. And we're going to copy these into StatCrunch. You don't want the total, okay, because it'll make your bar look weird. And we're going to go to statcrunch.com. Okay. All right. So here, we're going to sign in and register, sign into StatCrunch. Now you could do this same bar graph in Excel. It's not particularly difficult. StatCrunch, we are using it for all of our statistics stuff. Click on this big orange button here. But we could have done pretty much everything in that we're doing in StatCrunch. We could have done it in Excel. It is able to do normal curves and stuff like that, but StatCrunch has a lot more visuals than Excel does. We'd have to build some of the visuals ourselves in Excel. All right. And we're going to just paste it in here. So, nope, that didn't work for me at all. Uh, let's try that again. I bet we're gonna have to do this column by column, aren't I? Oh, all right. Do this column by column. All right. So highlight just the color column. Again, don't include the total. Um, and click on variable one and paste. You still didn't put, I want the color as the header. Color. Okay, that's fine. It's okay if I have a space there. All right. My numbers, put those here. Oh, why is it doing that? That's annoying as heck. All right, there we go. Good enough. Some reason when it was pasting, it was inserting a row, but you could have also typed them. You could have typed orange, blue, green, whatever. All right, so now that we have that, uh, our question for number 3 is create a bar chart of your M&M data in StatCrunch. Displays each color with its value shown above the bar. Okay, paste the bar chart here. So to do that, we're going to go to Graph, Bar Plot with Data. Okay. Select the column number. Okay. We want the value above the bar. And then let me get the labels. So group by color. So there's a drop down right here for group by color. So we're putting the number is going to be the value of the bar, group by color, value above the bar, and hit compute. Well, that didn't do it for me. That made that, all right. That looks terrible. That's not what I wanted. Yeah, we'll try that again. Okay. Yeah, that's not doing it. What am I doing wrong? What am I doing wrong, Elaine?
I don't know. Let me look. I just watching it looks right. Do you
Is that not
see
the bar
bar
plot
plot?
then?
What if you do a histogram? See what that does because you have numbers. See if it does.
Yeah. The problem is that a histogram, your x-axis is going to
Yeah,
be quantitative, and I want my
yeah.
x-axis to be the colors. Yeah, so
Wonder.
I mean, I get this.
Hmm. Weird.
Select graph, bar plot with summary. Oh,
Okay.
I was doing with data.
Yeah.
Sorry, guys. Graph,
I'm
bar
sorry.
plot with summary. Categories are my colors, my counts are my numbers. So bar plot with summary, and then click value above the bar. All right, we'll try this. Categories in color, counts in number, and value above the bar. All right, there we go.
There it is. That's weird though.
Oh yeah,
The
I thought it
data.
was with data because I have the data, but
Yeah.
yeah. Um, okay. So now that I'm looking at this, um, now you can start analyzing and you can see trends and stuff a lot easier. You can see this 17, like how much smaller it is compared to the others. So you can see that uh, it's it's a little bit more than half of the largest one, but it's still a pretty big drop. So, okay, that looks good. So we will grab a screenshot of this, paste it in for number 3. Okay. All right. Create a pie chart of your Skittle data that displays each color, again with its count. Uh, put the Skittles into there, and we're going to do pie chart with summary. Okay. So let me go back to my data here for Skittles. Grab these. Need this anymore. Here's my colors. All right. Again, you could just type them in if you want. If you're lazy, if you don't want to copy and paste. I'm lazy, so I'm just gonna copy and paste. But that's also muscle memory because a lot of times when I'm looking at data, I'm not looking at 5 rows of data. I'm looking at hundreds or even thousands of rows of data, and then typing it in is not an option, right? So, okay, so we go to graph, pie chart with summary. Our categories are oh man, I should probably name these different things. Uh, colors for Skittles and numbers for Skittles. Whatever. Pie chart with summary. It was the bottom ones anyway. So color is my categories, number is my counts, um, and then just hit compute. You don't need to check anything to because it will show the value. So except I forgot about this part. It's going to show it, but all your colors are going to be jumbled up. So my orange is red, my green is blue. Oh, it's annoying. So, um, there probably is a way to tell it to color them correctly. All right, so I'm gonna just copy this though. So I'm fine if we just put this monster pie chart in here. I've already complained about pie charts before to you guys, so I'm not gonna do it more. But actually, so there's an actual psychological effect called the Stroop effect by a guy named Stroop that when you have this kind of situation, I point to this shape here and I say, what color is this wedge of the pie? Um, it takes our brain an extra second or so to process that, oh, it's not orange. The color here is red, even though it's labeled differently. So, and actually, there's a game based on that. There's two games that I know of based on that effect. One's called Stroop, but it's a fun one. Um, okay, so here I can see that my purple is smaller than my others. Um, it's hard to see whether it's half of so my biggest one is yellow. It's hard to see whether it's half or more than half or less than half. And again, this is because humans are very good at estimating the sizes of rectangles. Um, but pie charts like this, it's a little bit harder for us. If we had done a uh, a, a bar chart, I think it would have been a little cleaner for us. So you can see that for my Skittles, my purple is more than half of my yellow. So, whereas here, I guess, yeah, it's hard to see. Anyway, uh, that's it for today. Just grabbing the data and doing some initial analysis. The initial analysis, you know, is uh, just taking a look at it, seeing if there's any patterns or anything like that. Once we get to the Chapter 9 project on Thursday, we'll do some much deeper analysis involving, normal distribution and some actual calculations and the central limit theorem and checking all of that stuff. So, all right. So we need to submit these. So let's do our picture one first, info and pictures. So we're going to go to share. Change this to anyone with the link. The access is anyone with the link. Copy that link onto your clipboard and then click on the info and pictures one in Canvas. Do try to submit the right one to the right thing. I won't mark you off if you switch them, but it just is annoying. So and then we'll paste that in here and I'll submit our assignment. I got rocket ship confetti. All right. And then same thing, we'll go back to the data and the graphs. Click on the data and the graphs. All right, now go to that one, and we need to share that one as well. Data and graphs. Change my restricted to anyone with the link. Copy that link and submit that here. By the way, you're going to want to make sure you saved the location of that data set. I got panda confetti this time. Um, so this data set that I've got saved in uh let's see, where did I put it? I put it in when I did file make a copy. I put it in my fall 2025 folder. So if you put it in my drive, that's fine. But we're going to be referencing this data for the Chapter 9 project, Chapter 10, Chapter 11. So unlike previous projects where maybe you never look at it again, we're going to need to be able to get back to this data, okay? Um, all right, so uh, that's that's it for that. Uh, if you have any questions, feel free to stick around. But that's it for today. Go enjoy some candy.
They're all going to enjoy their candy.
Okay. I don't have anything for you, Elaine, unless you do.
Okay.
No.
No, that's
Talk
awesome.
to you later.
All right.
All right.
Catch up.
Bye.